Alright, this is the last section in 5.6, inverse trig differentiation. So basically there's 6 functions like arc, sine, arc, secant, arc, tangent, and we've got to find the derivative of all that. And there's some proofs at the bottom, like I can talk about some proofs, I'm not really going to. You can look in your notes for that, I'm not going to spend time on the proofs, but we want to differentiate inverse trig functions. So here we go. So the derivative of arc sine is u prime over the square root of 1 minus u squared. And so basically that's what it is. So this piece down, whatever that expression is, it's squared, 1 minus u squared square rooted, times the derivative of that piece. Arc tangent is u prime over 1 plus u squared. All right. Arc secant is u prime over the absolute value of u times the square root of u squared minus 1. So absolute value and u prime, depending upon what they could be, you might get away with not putting absolute value bars there. It's not a big deal. For some cases it's more important. So you've got to kind of pick and choose the way you can do that. So now the right-hand side, the arc cosine, arc cotangent, arc secant, or arc cosecant, are exactly what these are, just with a negative out front. So anytime it starts with a c, it has a negative, so it's negative u prime over square root of 1 minus u squared. This is negative u prime over 1 plus u squared, and this is negative u prime over absolute value of u times the square root of u squared minus 1. I don't really know of a good way to memorize those other than maybe memorizing these ones, and then the c's are just negative. I'm not sure, but you got to do that. Sorry. I'm not going to prove anything. I don't want to waste your time, and I don't want to waste my time. So let's get into some examples here. So this is, remember, arc sine is u prime over square root of 1 minus u squared. So then u prime is 2 over square root of 1 minus 4x squared. And that's it. That's as far as I can go there. Arc tangent, remember, is u prime over 1 plus x squared, or x squared plus 1, doesn't really matter the order. And then I'm going to get 3 over 1 plus 9x squared. Okay? Or 9 plus 9x squared plus 1. It doesn't really matter how you want to write the denominator, because it is pluses, right? It is adding. Arc cosecant of the square root of x. So the derivative, so arc cosecant, remember, is negative u prime over square root of 1 minus u squared. So u prime is going to be 1/2 times x to the negative 1/2. That's what u prime is. So I get negative 1/2 x to the negative 1/2 over square root of 1 minus x, right? Because square root of x squared is x, so that's fantastic. Now let's kind of clean this up and tidy this up a little bit. So that's going to equal negative 1 over 2 square root of x times the square root of 1 minus x. Now you can combine those if you wanted to and get square root of x minus x squared, but that's not a big deal, that's fine. Arc secant of e to the 2x. So remember, secant was the derivative of the expression, which is e to the 2x times 2 over the absolute value of the expression, e to the 2x, times the square root of e to the 2x squared minus 1. So let's clean that up. So it's 2e to the 2x over absolute value of e to the 2x times the square root of e to the 4x minus 1. Well, if we think about it, this down here can never be negative. Okay, e to anything is always going to be positive. So those absolute value bars don't matter. And then this and this are the same, so those can cancel. So I'm actually end up with 2 over square root of e to the 4x minus 1. And there's your derivative there. Okay, let's get one more equation, one more problem, and then we'll be good to go. What are the points of inflection for the graph of y equals the arctangent of x squared? So how do we do this? Well, this is a little bit of a chain rule. So if we say y is equal to the arctangent of x squared, and then if I say y prime, the outside function's got to come out, times the arctangent of x this goes now 1 times the derivative of arctangent of x, which is 1 over 1 plus x squared. Okay, so that's your derivative. All right, but remember, points of inflection is the double derivative, so y double prime. So I'm going to rewrite this as 2 times arctangent of x over 1 plus x squared. Okay, now I got to find out y double prime. This is quotient rule. Okay, quotient rule is the low function, low-d high minus high-d low, low-d high. Okay, so low, so which is 1 plus x squared, times the derivative of the top function. Well, that's just 2 over 1 plus x squared, minus the top function, which is 2 arc tangent of x, times the derivative of the bottom function, which is just 2x. Okay, all of this is over the bottom function squared. So that's equal to, that's going to cancel, that's just 2 minus 4x arc tangent of x over 1 plus x squared squared. Okay, and what I want to do now is, this is the second derivative, okay, which means in order to find points of inflection, I got to find out when the double derivative is equal to 0. So if I actually try to solve this, this is the same as saying 0 is equal to 2 minus 4x arc tangent of x. And if I actually plug this in my calculator, okay, you plug this into your y equals calculator, you're going to find out that you're going to get 2 answers. So x is equal to plus and minus 0.765. So those are the values in which your double derivative touches the x-axis. Okay, that's what you want to find. You want to find the zeros of this function. So find the zeros of this function, and you'll find that it happens at 0.765 and then negative 0.765. Okay, that's it for this one. Deuces. See you in the next one.